Dear learners, I welcome you all to this video program on the distribution of temperature in the oceans. In the previous video programs of this block on hydrosphere, you have already studied about hydrosphere, its different realms, and how the water exists on earth in different forms like solid, ice, liquid water, and as in the form of water vapor in gaseous state, and how these different states of water are connected together in a hydrological cycle. So you have also studied about different relief features of the oceans like continental shelf, continental slope, continental rise, deep sea plain, mid-oceanic ridges, oceanic deeps and trenches, sea mounts and geodes. You have studied in detail the different relief features of the oceans in three major oceans of the world like Atlantic Ocean, Pacific Ocean and Indian Ocean. In this video program, we will study about distribution of temperature in the oceans. Temperature is an important physical property of seawater. We will study about the processes related to the heating of the oceans. We will also study about the horizontal and vertical distribution of temperature of the oceans. So, we all know that sun is the major source of heating of the earth's land, atmosphere and water systems. You have already studied about insolation, which is nothing but incoming solar radiation of the sun, and due to which it heats up the land and water surfaces. So, oceans get heated by the incoming solar radiation of the sun. There are other processes also which heats up the oceans, like heat is received from the interior of the earth near the ocean bottom, which is distributed through convection currents to the upper layers of the oceans. Another way of distribution of heat in the oceans is due to various chemical processes which generate heat, convection of sensible heat from the atmosphere, condensation of water vapor and transformation of kinetic energy into heat energy by due to various vertical and horizontal movements of ocean water also generates energy and heat into the ocean water. Also, compression of sea water at greater depths of the oceans leads to the generation of heat. However, this amount of heat is very negligible compared to the sun and other sources which heats up the oceans. Now, when we study about the temperature of the oceans, you may recall that heat is a form of energy and temperature is the measure of its intensity or the measure of the degree of hotness of an object. So, while studying the temperature of the oceans, it is significant that oceans are having a particular temperature, and so it supports all life forms in the oceans and their types and distribution at various depths in the oceans. Temperature also controls the movement of large volumes of ocean water, which we will study in the next video programs related to the movement of ocean water like tides and currents. And now we should also learn that there are three types of thermometers used for measuring the surface and subsurface temperatures of the oceans. Both temperatures are important for the study of oceans. So, standard type of some thermometer are used for measuring the surface temperatures, and reversing thermometers or thermographs are used for measuring the subsurface temperatures of the oceans. The water in the oceans is collected through Peterson-Nansen water bottle and Ekman water bottle. Now, in this figure you should see there is one Ekman water bottle which I mentioned are used for collecting sample of water for measuring the temperature of the oceans. This is an open source image, so I have used in this presentation. Now, when we come to study the daily range of temperature, we should know that difference between the maximum and minimum temperatures of the oceans of a day is known as the daily range of temperature. it is related to the balance between the incoming solar radiation and outgoing long wave terrestrial radiation. The incoming solar radiation is short wave and outgoing terrestrial radiation is long wave. You must have studied about these when you have studied the block on atmosphere. You are familiar with these terms. Now the maximum temperature is reached at about 2 p.m. and the minimum temperature of the oceans is reached at about 5 am. Now the factors affecting the daily ranges of temperature of the oceans are the sky conditions, stability and instability of air and nature of the sea surface. So sky conditions, when the sky is clear, so there is greater amount of incoming solar radiation coming into the ocean surface and heating up the oceans, and greater amount of heat is lost through long wave terrestrial radiation also when the sky is clear. So there is high diurnal range of temperature when the sky is clear. Contrary to this, when the sky is cloudy or overcast with clouds, lesser amount of solar radiation reaches the ocean surface, and the heating is less compared to the condition when the sky is clear, and so lesser amount of heat also is lost. So outgoing terrestrial radiation is also less in case of cloudy conditions. So the diurnal range of temperature during cloudy conditions is less. Now related to stability and instability of air, if the atmosphere is calm and stable, there is lesser mixing of air and hence diurnal range of temperature would be high. Compared to the condition when the atmosphere is unstable, so there is greater mixing of air and the diurnal range of temperature would be low. Now in case of nature of sea surface, high density of water found below the sea surface at greater depths reduces the conduction of heat. So nature of sea surface also affects the diurnal range of temperature of the oceans. Now in this table you can see that there are two conditions when the sky is overcast and when the sky is clear, and when there is a moderate to free breeze. So you can see when there is moderate, when the sky is overcast, their average temperature range is only 0.39, while when the sky is clear, average temperature range is higher, like 0.71. And this condition is shown when there is moderate to fresh breeze. So the atmosphere is not that calm, and in the later part you see the atmosphere is calm and very light breeze is there. So the overcast conditions leads to greater diurnal range of temperature, that is 0.93, and when the sky is clear it is even greater. Compared to the previous condition when there is moderate to fresh breeze. So you can compare and understand it in a better way with the study of this table. Now annual temperature range is the difference between the annual highest and lowest temperatures of the ocean waters. The maximum and minimum temperatures are recorded in August and February respectively in the northern hemisphere and vice versa in the southern hemisphere. Now when you read about the isotherms of the land areas in the block atmosphere, you must have studied that extremes of isotherms are studied in July and January. But in case of oceans, the extremes of isotherms, extreme temperatures are studied in the months of August and February, because water is having high specific heat capacity, and so it takes more time to heat up the water and cool the water compared to the land areas. So instead of July, we study the summer isotherms in August, and instead of January, we study the winter isotherms in the month of February for the northern hemisphere, and the condition gets reversed for the southern hemisphere. When the northern hemisphere is having summer, the southern hemisphere is having winter. Annual variation of incoming solar radiation also affects the annual temperature range of the oceans. Annual temperature range also gets affected due to ocean currents and prevailing winds. because we all know that warm ocean currents pile up warm water near the coastal areas, and so the range of temperature, annual temperature range gets higher in case of coastal areas where currents are onshore compared to those where the currents are offshore, because offshore currents will remove the warm water from the coastal areas, and so there will be upwelling of cold water from from greater depths of the oceans, and so the annual temperature range would be lesser in case of cold ocean currents. And so prevailing winds are also related to when the prevailing winds are towards the coastal areas. They heat up the coastal areas, like warm winds, trade winds heat up the coastal areas, contrary to the cold winds which cool up the coastal areas. So the temperature range is affected by ocean currents and prevailing winds. Average annual temperature range is of the order of 10°F. However, the small landlocked seas have higher annual temperature range, which is of the order of 20°F. Factors affecting the horizontal distribution of temperature of the oceans. The average temperature of the surface water of the ocean is 26.7 degrees centigrade. The amount of insolation decreases from equator towards the poles, and this decrease is generally of the order of 0.5°F per latitude. So we all know that equatorial areas and its adjoining areas receives more incoming solar radiation, so greater amount of heating is done in the region adjoining to equatorial areas and tropics, and so the temperature reduces further northwards and southwards towards the poles. So the temperature of the ocean water also reduces towards as we move from equator towards the poles. Location and shape of the seas also affects the horizontal distribution of temperature of the oceans. Like in the northern hemisphere, there is greater proportion of land areas, so oceans are more in contact with the land areas, so they get heated up quickly and cools quickly. So the temperature and the heating of the oceans is related, and compared to the southern hemisphere where there is a greater proportion of oceanic areas, so the isotherms in the southern hemisphere are more regular, and there is no such drastic change in the temperatures. Now prevailing winds and ocean currents also affect the horizontal distribution of the temperature of the oceans, like I explained previously also. And local variations in weather conditions like storms, cyclones also affect the horizontal distribution of temperature of the oceans. Besides, submarine ridges prevent the mixing of water on the both sides of the ridges, so they also affect the distribution of temperature of the oceans. Now we see the horizontal distribution of temperature in the Atlantic Ocean. So Atlantic Ocean is having effect of a warm ocean current like Gulf Stream, due to which the decrease of temperature with increasing latitudes is relatively low in case of Atlantic Ocean. Highest temperature is recorded at about 5° north latitudes, and lowest temperature is recorded at about 80° north latitudes and North Pole, and between 75° south latitudes and South Pole. We will study these through with the help of figure also. Let me first explain the horizontal distribution of temperature in Pacific Ocean. Average annual temperature of the Pacific Ocean is slightly higher than the Atlantic Ocean and Indian Ocean. The lowest temperatures is about 3.3 degrees centigrade, which is recorded near New Scotland, and the highest temperatures is about 32.2 degree centigrade, recorded in about Western Pacific Ocean. The isotherms are almost parallel to the lines of latitudes in the Northern Pacific, and isotherms run parallelly in the Southern Hemisphere. Now horizontal distribution of temperature in the Indian Ocean. Highest temperature is 28 degrees centigrade and is recorded at in the Arabian Sea as well as Bay of Bengal. Some of the enclosed seas record still higher temperatures like Red Sea 30 degrees centigrade, Persian Gulf 33 degrees centigrade, In the southern part, the isotherms become almost parallel to the lines of latitude, and difference in the ocean surface temperature and air above it sometimes results in the formation of fogs over seas and oceans. Now you can see the horizontal distribution of temperature of the oceans in August. This is having the summers in the northern hemisphere and winters in the southern hemisphere. As I mentioned that in Atlantic Ocean the isotherms are running a little bit northwards, like this is due to the effect of warm ocean current like Gulf Stream, North Atlantic drift, due to which higher temperatures are found at higher latitudes. Above you can see the Scandinavian plateau, Scandinavian region. The isotherms are diverted a little towards the north, and southern hemisphere is a little more regular. The isotherms are almost parallel. You can see in both Pacific Ocean, Indian Ocean and Atlantic Ocean, the isotherms are almost running parallel, and so there is effect of land areas in the northern hemisphere, due to which isotherms are slightly diverted because of increasing temperatures of the land. Similarly, in the month of February, horizontal distribution of temperatures of the oceans, you can see February is the month when we experience winters in the northern hemisphere and summers in the southern hemisphere. So all the isotherms are a little bit shifted towards the south. You can see compared to the previous one, the August one, you can see the isotherms are shifted, like 5 degree centigrade isotherm is shifted towards the south. So you can compare both the figures. Surface water temperatures of the oceans in the northern hemisphere. You can see that in the northern hemisphere different latitude ranges are shown in the left part of the column in this table, like 0 to 10 degrees to 60 to 70 degrees latitudes, and different oceans are shown in the adjoining columns like Pacific Ocean, Atlantic Ocean, Indian Ocean. You can see that the surface water temperatures are lesser at Pacific Ocean compared to Atlantic Ocean, like 5.74 degrees centigrade is reached about 50 to 60 degree latitudes in Pacific Ocean, compared to the Atlantic Ocean where this temperature is reaching at about 60 to 70 degrees. You can compare the oceans this way, the surface temperature of the oceans in the northern hemisphere, looking at this table. And in the southern hemisphere you can see the decrease in temperature is more compared to the previous table, because you can see that between 60 to 70 degree latitudes in Atlantic Ocean temperature has reached about minus 1.3 degree centigrade, and this is because of greater proportion of water in the southern hemisphere compared to the northern hemisphere, due to which temperatures are reducing at a higher degree as we go from equator towards the poles. We have studied the horizontal distribution of temperature of the oceans. Now it is also important for us to study the vertical distribution of the temperature in the oceans. The temperature of the surface water is obviously higher compared to the temperatures at greater depths as we move from the surface to greater depths below the surface. So this is because surface water gets heated due to incoming solar radiation, and this sun's rays penetrate effectively only up to a depth of 20 meters from the surface and is hardly noticeable beyond a depth of 200 meters. So as we go from surface to greater depths below the surface, the temperature of the ocean water decreases. So vertically, oceans can be divided into two zones. One is photic or euphotic zone, which is from the surface to 200 meters of depth, and the aphotic zone where there is no light reaching the oceans, which is beyond the 200 meters depth, where no light penetrates, and it is the darker zone of the ocean. one more thing is important, that the rate of decrease of temperature with the depth can be seen only effectively up to 2000 meters, as it has been found due to various oceanic expeditions. Thereafter, the rate of decrease that is beyond 2000 meters, the rate of decrease becomes almost stagnant. You can see this with the help of this table, temperature of the oceans at varying depths. You can see that the temperature of the oceans is decreasing from depth in 100 fathoms is given in the left side, and 100, 200, 500 fathoms depth is given, and you can see that the temperature is getting reduced from 60 to 50 degree Fahrenheit to 40.1 degree Fahrenheit. And then since the depth is increasing, you come to the right portion, you see the depth is increasing from 1000 to 1500 to 2500. The temperature is decreasing like 36.5, then 35.3, and then only 35.2. So between 1500 fathoms and 2200 fathoms, you see the decrease of temperature is only, it's become stagnant. In this table also you can see that there is comparison of temperature at the sea surface and at varying depths at different latitudinal zones. You can see that the surface temperature is decreasing from 0 to 10 degrees to 60 to 70 degrees, and you can see that the surface temperature is decreasing from 26.83 degree centigrade to 4.26 degree centigrade as we go towards higher latitudes. And now in coming on to the depths at 7.30 degrees north latitude, you see different depths are shown, like 0 meters, that is the surface temperature, and then 100 meters, 200 meters, 400 meters, 800 meters and 1000 meters. So you see that temperature is also decreasing at various depths, like at the surface it is 26.86 degree centigrade, and at 1000 meters depth it is shown that 4.81 degree centigrade. So the rate of decrease of temperature also changes with increasing depths. And this also varies as we move from equator towards the poles, because the rate of decrease is higher. The rate of decrease is higher along the equatorial belt. The vertical decrease of temperature is higher along the equatorial belt compared to the poles, because we see that as we move from equator towards the poles, in this table you see the temperature of the surface water is also decreased to 4.26 degree centigrade. So the temperature at greater depths also becomes almost equal to the surface temperature at higher latitudes. Now upwelling of water from below also affects the rate of vertical decrease of temperature of the oceans. It is high in case of onshore winds compared to the offshore winds. And similarly, enclosed seas record exceptionally high temperatures at even greater depths, as I have explained earlier. Submarine barrier also affects the vertical distribution of temperature of the oceans because of lesser mixing of water. And so in this video program we have studied about the heating process of the oceans, diurnal and annual temperature range of the oceans and factors affecting them, factors affecting the horizontal distribution of temperature of the oceans, and also the horizontal distribution of temperature in different oceans in the months of August and February. We have also studied the vertical distribution of temperature of the oceans and factors affecting them. In the next video program, you will study about another important and unique property of the oceans, that is distribution of salinity of the oceans. Thank you.